Hi, this is Phil. Phil's got a PhD in laser physics and he's a patent attorney, which means he's on the dark side of the force, but he's decided to come to the good side of the force and become the new EEVblog apprentice. So he's got to learn the correct tongue angle. So I'm going to teach him that, and hand us the left-handed screwdriver there, Phil.
Yep.
It's a right-handed one.
Come on.
Gee, you've got to learn.
Oh, let's get this wrong.
Noobs. I don't know. He's got a lot to learn. Anyway, we're going to calibrate our Makerbot here and print something. Let's go. And here's our finished Makerbot Thing-O-Matic. And it's serial number 6887. There it is. And it looks rather neat. You've seen these before. It doesn't light up like some of the other ones do. They've obviously installed some lighting inside. Mine doesn't have that. The power supply was really dodgy to install that, but it's apparently the type supplied with this one. And I've got the new Mark 7 step extruder inside there, and that's the Z-axis platform. I haven't cable tied down any of the wires yet, so all the wiring is all loose in there because I want to figure out what the maximum range of the platforms is before I actually do that. But that is a Makerbot Thing-O-Matic. It's ready to go. So we'll plug it in, we'll calibrate it, and we'll give it a whirl. And our first print. Wonder what we'll print. Now here's one thing I don't really understand. They've got these really nice bearings on here that the shafts slide into, but this one on this side doesn't have the bearings on either side, and there's a bit of play in there. I'm not sure if you can actually see that, but I can actually wiggle that up and down, and I'm not sure why there's no bearings in there. They didn't supply them, and they didn't tell me to actually put them in. Strange, but anyway, that's the Y-axis platform there. We've got the X-axis platform on top here. That one does have the bearings on either side, and it feels reasonably smooth. And as you can see, the wiring inside these things is really just hanging there, basically. So it is a bit messy on the inside. And on the top side here is our Z platform, which is this motor here with this worm screw drive there, and that moves this entire platform on the top here. And if we get down and we take a look at the underside of it there, you can see the entire Z-axis platform move, and it's got the step extruder on there where your filament goes in the top here. It all heats up. It's got a heater in there, a ceramic heater, plus a thermal overload and a thermocouple as well. There's a safety cutout PCB over here, which is designed to cut it out if it goes over temperature, and that's about all there is to the XY mechanical platform. It's fairly simple, but the build itself is fairly complicated. It took probably 15 hours for the two of us to actually fully assemble this thing. Alright, we've got our Makerbot switched on and connected to USB, and we've updated the firmware. So we're going to disconnect. I'm going to reconnect down here, and we're using the Replicator G program and connect to the unit, and we're connected. We've updated the firmware. We've gone through the process, and we're going to do the calibration. So what we do is we go up to File up here and Scripts, Calibration, and we run the Thing-O-Matic calibration G code, and then we hit the build button. So the script is in there. We hit build, and now it's telling us move the build platform until the nozzle lies in the center, and then turn the threaded rod until the nozzle just touches the surface without pressing onto it. Okay, so we want to change that. We want to put it directly in the center there. So we want to put the nozzle just a smidgen off the surface. Is that just off?
That's just off.
Just off. Half a bee's dick off the surface there, and that looks like it's in the center. Near enough. I'm not sure if you have to do this calibration routine every time, because I'm not sure that the machine knows where the absolute position of those sensors is. Tongue angle, Phil? Alright, so what we're going to do is we'll hit yes, and here we go. Woohoo! There it goes. And it should hit the top micro switch in there, the limit switch, and bang, and this thing, and the build platform is now centering itself back to that position. The micro switch switched on there for the X and the Y. So our 3 limit switches clearly work, X, Y, and Z limit switches, and we're done. That's the calibration. Simple. Okay, so now we're we're in the control panel software, and we're going to test the tool head temperature and the heated build platform temperature. So it tells us to type in a target temperature of 225 degrees C for the tool head. So we've done that and pressed enter, and as you can see, it's ramped up there. That's our target temperature. In blue there and red, you can see the temperature is actually ramping up, and it says to do 120 degrees. Is that right, Phil? 120 yep. For the build platform. So we type that in, press enter. Our target temperature has jumped up there in yellow, and we'll see the white line there, the build platform current temperature, ramping up. So both of those will eventually ramp up to their set temperatures, and they should remain there. They shouldn't overshoot or anything like that. So this could take a few minutes. And the tool head didn't overshoot, it's maintained, it's ramped up and then maintained the set temperature. The build platform's not quite there yet, but it's on its way. Okay, our tool head has reached temperature, and now it's telling us to stick the filament into the, I've chosen red, because red goes faster. Stick it in, and then what, Phil? Well, it seems that we've got a problem. No matter how hard we push in here, no matter how many times we actuate the motor and try and get the filament to grab in there, it's just not working. So, I don't know, plan B. Well, we tried this fluoro green one and we did get it to grab. So, we're supposed to see a thin bead come out of the bottom. We're still up to temperature, 225. Oh, yep, there we go. Got it. Woohoo! There we go. Switch it off. Press stop. Awesome. There you go. We've got a hanger. And look at that. There we go. That's the first thing we printed. Bit of hot snot. Hey, yeah.
Floss.
Floss. Beautiful. Works a treat. Green. Okay, we're ready to print something. We've loaded in Yoda's lightsaber. Very cool. We've put it vertically. We've centered it on the platform and flipped it. What do we do now, Phil? Generate G-code? Alright. I assume it knows that, well, it fits within that area. I'm assuming we're going to have enough filament, and generate G-code. You have made changes to this model. Any unsaved changes? No. There we go. Python interpreter. Would you like to visit? Fail. Come on. Wah, 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 wah. Okay, we've installed the stupid Python interpreter, and I've scaled that down really tiny. We want this thing to print. I have no idea if this is a good first example, but let's generate the G-code. Save the model. Nope. There we go. It's doing something. Now what do we do? Okay. Oh, how do we set up our... Oh, use raft. Okay. Yep. Yeah, use printomatic. Got it. Step layer height, 0.3 millimeters. The perimeter thicker. Well, default to 1. Yep. Feed rate, 30 millimeters per second. Okay. And we're using a 1.75 millimeter ABS Mark 7, I'm assuming. That's the different material. Okay, well, we're definitely using ABS. We're not using PLA, so What's this plastic? Material type ABS. Filament diameter 1.8, I think it is.
Yep.
I don't know. We'd have to actually get the calipers out and measure that.
Between 0.175 and 1.8.
Okay, that'll do. The extruder, nozzle diameter, no idea. 0.4, yep. Okay. Done. Do we generate G-code? Not automatically generate when building. Go! Phil says go.
Go.
We're going. We're generating. We're almost there for the total number of layers for the inset. The inset procedure. Now we've got to do the fill procedure. How many procedures are there? More than you can poke a stick at. You can see the different processes it goes through. Carve process, preface, inset, fill, speed, temperature, and raft procedure. But it's still going. Not done yet. Man, it's taken all day. And there were comb, cool procedure, reversal procedure, and it's done. Woohoo! It's printing. No, it's moving. It's doing something. It's given us an estimated build time on the software of, what is it, 1 hour and 28 minutes. Ah, man, we're hoping to do this before the gym. Oh well, have to head home and come back later and see if it's finally built. Do I dare leave this thing on its own, or will it replicate and start Skynet? Uh-oh, something's gone wrong here. It's hitting the end over here, and there's no end stop. It just won't go any further. And, nope. No, it's printing. It's printing, but it certainly didn't do it in the center. No, it didn't center on the pad. Why not? We went through the calibration procedure. No, our first print is a failure, and it doesn't stick to the aluminium surface. If you actually have a look down in there, we probably should have put that mylar sheet on, but it's it's all just curled up. So that's our first print. It's a nice pattern though. I rather like it, but there you go. First print, fail. Alright, so what we've done now is we've made the current position 0 in the control panel. So we've moved it so it's in the center, and we've done that, and we're building again. But, maybe we should put down some mylar tape, but why is it going back up to start? Well, there you go. Okay, we're at least getting somewhere now. We haven't figured out how to center it properly on the pad yet, but we managed to stick on some mylar very quickly before we started this print job. I think it's probably laying down some sort of base, maybe, because that doesn't look like our object, so not sure what it's doing there, but it seems to, it's almost like printing out too much. No, that's doing a small amount. There we go, okay. So it is controlling the amount of... And now it's decided that it needs to do another print on the other side. What? What's going on here? Wow, I... no idea what it's doing. It's almost as if it's printing it down sideways. Well, fail, look at that. It's just picked up the whole lot of it and dragged it across. This is pretty awful. I think we have some sort of calibration issue. Some sort of programming issue. Look at that. It's just ridiculous. What's it doing? Crazy. And we've got the heated build, we've got the proper heated build platform and the mylar tape, and it just looks nothing like the orientation that's on the unit itself. Crazy. Oh, it's building a bait. It's probably building a... at least it's sticking now, right? It wasn't sticking before.
Yeah.
Well, that's looking good because it is sticking, so I'm pretty happy with that. Although if that's 0.3 millimeters on the monkey's uncle, that seems a bit more than that. See, it's lifting up, it's doing all sorts of weird and wacky stuff. It's almost like it's putting out, yeah, nasty sounds. It's like it's putting out too much stuff and not moving and not stepping high enough. So I think we need to tweak some of those values. Hey, ta-da! Oh, that's pathetic. I think we should probably, that's our best bet though, is to take that off and file it down better and tweak that. Yeah, I can see it go a bit slack there. I think the belt went a bit slack, possibly. So I think that's I think we'll find that's probably our culprit in there. So there's our second print, and that is a complete and utter fail. It was supposed to be a Space Invader character, but nothing. But look, it built this, what looks like that zigzag base there. It built that lovely, but then it sort of just ran into itself, and it did all sorts of weird stuff. So we think it's actually slipping. The belt must be slipping somehow to give that. But why it gave that perfect zigzag pattern to start off with, we're not sure. But I think we'll probably take off the X-axis and try and tweak it, I guess. Alright, so we've taken it back out there. We're taking the X platform, the build platform off, and we're going to try and file down these bits in here a little bit bigger, because we think that's where it's getting caught up or something like that, and maybe causing it to slip on the cogs. Maybe. Fingers crossed. No, scratch that. We think that this cog is possibly too high up, because it's much higher than the cog in there, which you probably can't see, but due to the light. But yeah, we think maybe we'll try that first rather than go to the effort to file out that some more, because really it's going to have a hard time slipping when you've got a nice toothed belt like that in a proper cog and it's all tightened up. So possibly the height of that might be doing something. So we'll try and lower that first. I think we're still squirting out too much, if that's the correct terminology. Extruding too much, squirting out too much.
Never takes your fancy day.
Yeah, alright. But that's more promising though. Well, at least we've gotten further, right? The base is a lot further. And it's like, and it is in the center. Whereas yes, before it was way off. It sort of did, yeah, it started from here actually, rather than it started over one side. I think, yeah. But it's not filling in that as a complete square. So I'm not sure what's going on there. But this is good. This is very happy with this. Yep. That seems to have made a big difference. Yeah, that's very promising. I like that. Oh yeah, that's smooth, fast, brilliant. I think that was our issue. Wow, that's all it was.
Yeah, it's looking good.
Here we go. Here we go. It's drawing our pack. It's drawing our Space Invader. Oh, brilliant. Oh, brilliant. Oh, now we're excited. Oh, yes. Perfect. Woohoo. Winner. Now I wish we printed something more exciting than a Space Invader. Anyway, we can print anything now. This is great. That's why, because it's already cooled and then it goes back in the other direction. And so it deliberately puts those ones like vertical and then starts drawing the thing horizontal, so the base horizontal. I think that's the reason.
That's definitely looking like a Space Invader now.
Yep. We get no slippage at all. That works perfectly. Actually, no, I think it's out.
reckon?
Unless it's like it's staggered. You see the layers?
Yeah,
They're staggered. I think there's something wrong there. Potentially. Otherwise, or it's designed like that. Or is it? No, does it look staggered? It's a flat object. I think it's out. Either that or we have a calibration issue with like how much it extrudes and temperature and stuff like that we need to tweak, but generally though, pretty done. Hey, finished! Ta-da! There's our Space Invader. And there it is. That's our very first Makerbot print. It's a Space Invader. It doesn't seem that solid. There seems to be something about it, almost as if maybe a calibration issue, perhaps in regards to setting the temperature or the amount of product which is extruded, because the layers don't seem to line up. They seem a bit staggered. So maybe we have some more belt slippage or something like that, perhaps. There's some of the very fine weaves. What is it, a raft? And yeah, I think we've still got layer alignment issues. Yeah, it definitely looks like we've got a Y build issue. Y is in this direction, X is across here like this. And if you see, the edge of it is fine. These walls on the side here are perfectly aligned. That indicates to me that there's no error in the X. There's no slip in the X axis motor, but the Y axis, this is why we can't see through the eyes of the, well, I guess you could say the eyes of the Space Invader character there, and why these sides here are not smooth, as they should be. They should be perfectly smooth. So that we think our motor is slipping somehow in this Y direction, like that perhaps, or there's something going on there. Okay, we're printing out the cylinder now to test our XY capability, and I think we've got it. I think it was just our belt tensionings that were slightly off. It seems to be fairly critical, but this cylinder is now looking very, very good. I love that sound when it draws a circle. It's brilliant, but this is really, I think we've cracked it. I think we have an absolute winner here. And there's supposed to be no flat sides, Phil. No flat sides on the cylinder, because that indicates a loose belt, apparently. So I think we've cracked it, and this will be our first real successful print. So now we just don't touch it, right? We don't breathe on it again, or at least don't touch the belts. There's that cool noise going around and it's building up this thing, and I'm pretty darn happy with that. So we'll show you that when it's finished. And there is our very first print, and it looks absolutely perfect. Woohoo! We've cracked it, Phil. That's a winner. That has winner written all over it. That is absolutely beautiful. There's no XY stepper, backlash or anything. We're getting no flat sides. So I think we have absolutely fluked the tension in on these belts, because that's all it was, really, was the tensioning of the belts. And the cylinder test is a very good test to do as a first print, to show you that that you're getting no backlash or over tightening or under tightening of your belts. Beautiful. Well, it looks like we spoke too soon. Our cylinder was absolutely perfect, so we tried to print our Space Invader symbol again, and we got this silly stepped thing again.
First one still looks like the best.
So it's, yeah, our first print. That's our first print, actually looks better than this print we just did. And we didn't change any settings at all. Our feed rate was still the same and all sorts of stuff. So really, that's all we can assume is that it was much more of a jaggy motion. So all we can assume is that the jagged, violent motion required to actually print this is actually offsetting, causing an offset in our y-axis in this direction like this. Because once again, the x-axis is perfect because these walls, side walls here, are perfectly, well, you know, fine, as good as, you know, as good as you can expect. But the cylinder, when that was printed, that was a very smooth motioned print. There was very silent, no jerky motion or vibration of the machine at all. But printing this thing was very jerky, and the thing jerks around and makes a lot of noise and does violent movements. So really, there's something wrong there. Maybe we have to drop the rate even further. And you can see the what is it? The raft on the bottom. That is what they build upon. So you'd have to cut that off, or sand it off, or slice it off, or something to get your nice smooth surface on the bottom, like you do on the top. But it actually prints that so it doesn't stick to the heated build platform. But there you go. Anyway, I think we've cracked that.
I think that's probably what we'll try.
Yeah, I think we'll try and decrease the speed, but yeah, I think we'll call it quits, because that is technically a win. It's just the machine works. Beauty. It's only a matter of just tweaking a few numbers and things like that, and we'll be sweet. So we'll catch you next time.